Find the derivative of the function given here as f of t equal to square root of t over t square plus 1, right? So this is the given function and our goal is to find the derivative of this. So let's try to do that. So how can we find the derivative of f with respect to t or f prime of t? How can we find this? So what do you see on the given function here? We have a square root function here. We don't have the direct formula that will deal with the square root, but what can we do? Actually, square root can be changed into this radical can be changed into the exponent form, right? So and then if that is the case, this can be actually written as t over t square plus 1, this expression raised to the power 1 over 2. That's how we can convert. Now if we have something on the power like that exponent form, we can actually use, here we have a function raised to the power something. So what can we do? We can use the generalized power rule, right? So we can use that. So if you are not sure what generalized power rule means, please watch the suggested video. Otherwise let's just try to apply this generalized power rule. But you know that generalized power rule is a particular case of the chain rule, right? So whatever is that, please revisit. If you don't know, was the video that will give you the idea of what generalized power rule means. Otherwise let's just if you know, let's try to apply this one. So how can we apply this one? So we have a function raised to the power something, right? If you have a function raised to the power something, the generalized power rule says that whatever in the power, right, over here we have 1/2. If the everything of this function t over t square plus 1 raised to the power 1/2, that power whatever is that, bring that power down, so 1/2, and then write that down as a coefficient, and then multiply by t over t square plus 1, whatever is the function over here, write that down as it is, and then everything raised to the power 1/2, whatever is the power, minus 1. So this is like a power rule, right? Bring the power down, write down the function as it is, subtract the power by 1. Okay, now after that, the generalized power rule is, don't forget, after you do that, multiply by the derivative of t over t square plus 1 with respect to t. Make sure you understand this step. We have used the generalized power rule. Whatever in the power, we bring that down as a coefficient. Whatever over here on the base function, we write that down as it is, subtract the power by 1, and we didn't forget to multiply by the derivative of this base function with respect to t. This is the application of the generalized power rule. We are done, but we are done in a sense that we apply the generalized power rule, but still here is the differentiation. We need to do it, right? We need to complete that, right? Then only we'll get the actual derivative of the function. So let's do that then. Okay, so let's focus for a moment. What is the derivative of this one, t over t square plus 1, because that's the only thing left over here, right? How do we find the derivative of t over t square plus 1? We can use the quotient rule, right? Because we have the quotient function here. So let's apply the quotient rule. So how do you find that? We need to look into what is the function at the top, right? What is the function in the top and what is the function at the bottom, right? And then to use the quotient rule, what do? We first write down the function of the bottom, which is t square plus 1, multiply by the derivative of the top, which is t, right? So derivative of t with respect to t, we need to know that, minus, leave the function of the top as it is, multiply by the derivative of the function of the bottom, right? And everything under that will be square of the bottom or the denominator. So that's what we do. So that's the derivative. By the way, what does that mean then? T square plus 1, right? So that is as it is, so we don't have to do anything with that. So write that down, but we need to find the derivative of t with respect to t, which is 1. Okay, nice, minus, and we have t there, right? Write that down as it is, multiply by the derivative of t square plus 1 with respect to t, which is, what is that one? What is the derivative of t square with respect to t? 2t, right? Okay, and what is the derivative of 1 with respect to t? 1 is a constant, so derivative of that will be 0. So okay, then this is just the 2t is the derivative of t square plus 1. and everything under that will be square of the denominator. If we want, we can like simplify a little bit. We can distribute by 1 over here, right? 1 times t square will be t square, 1 times 1 will be 1, so then we'll have just t square plus 1, and then t times 2t will be negative 2t square, right? Because we have that negative over there, so t times 2t is 2t square, but because of the negative we have that divided by square of t square plus 1. So we end up with having negative sorry, we can combine here, right? So t square and then 2t square, when we combine, what do we get? Negative t square plus 1, right? So, or 1 minus t square, whatever you want to call it, divide by square of t square plus 1. So this is the derivative of the function that we have over here, and then we find that out. So if that is the case, we can now bring that in over here. So our derivative of the given function will be 1/2 t over t square plus 1 raised to the power 1/2 minus 1, so that will be negative 1/2, multiply by this derivative that we have figured out here, right? So we just copy that, negative t square plus 1 over t square plus 1 and square of that. So this is the derivative. But if we want to further combine and then like or write down in a different form, what we can do is, let's see what is on the denominator, multiply all the denominator terms. So we have 2 here, and we have t square plus 1 to the power negative 1/2, right? So we can have that. So t square plus 1 to the power negative 1/2, and then we have t square plus 1 square of that, right? So square of t square plus 1. So these are the term on the denominator. Let's multiply them together and do the same thing on the numerator. So when we do that, we have t to the power negative 1/2 multiplied by 1 will be t to the power negative 1/2, right? So times negative t square plus 1. So that's what we have over here. I'm just multiplying the numerator by the expression on the numerator, right? And then the expression on the denominator, I'm just multiplying them, whatever terms on the denominator, whatever terms on the numerator. So that's what we get. Well, we can just leave it like that, or we could also further a little bit simplify. T to the power negative 1/2, if you change it into the positive exponent, that will be go down, right? So on that case, we have only negative t square plus 1 is in the numerator or at the top. At the bottom, we have 2 as it is, and then this one, when you change it into the positive exponent, this will be at the bottom, so t to the power 1/2. And at the bottom we have t square plus 1 raised to the power negative 1/2 t square plus 1 raised to the power 2, and since they have the same base, we can combine the power, right, by using the exponent law. So if you do that, this will be t square plus 1 raised to the power negative 1/2 plus 2, right? We just need to add the power. So on that case, negative t square plus 1 divide by 2 times square root of t, if you want to change that exponent into the radical, times t square plus 1 to the power negative 1/2 plus 2 will be 3/2. All right. Okay, that's also another alternative. Or everything, if you want to change it into the what was that on the radicals, then this will be 2 times square root of t, and then this can be changed into square root of t square plus 1 to the power cube. That doesn't look like a kind of the form I like. And actually, because we have square root of that, this can be square root of t square plus 1 to the power cube. This can be written as t square plus 1 times square root of t square plus 1. Oh, come on, many alternatives. So this can be also written then as 2 times t square plus 1 times square root of t times t square plus 1. But this is too much, right? So okay, well, if you like it, okay, if you like it, you can write down the other alternatives. I mean, otherwise, I mean, right over here the derivative is done, right? So this is the derivative of the function. What are the alternative you need it? I mean, you can try some other alternatives too, or maybe one of them would like fit on based on your desired, I don't know, but this is sufficient for you to find the derivative of the function. Okay, let me show you all the solution.